Hi, in this meeting, we are going to be discussing databases and how they should be structured in order to do your work better. So the basic idea here is, first of all, to discuss what a database is. I should say this is all very well covered in the textbook in chapter 4. So a lot of what I'm saying here is just kind of summarizing the value for applied research. So just to give a standard definition, it's a database is a collection of data about entities. That could be individuals or businesses, other types of units of analysis. And people will talk about structured or non-structured data, and the degree to which it's structured is going to depend on how the database is put together. What we'll be talking a lot about today is the relationships between entities. And that's what's going to be called a relational database, which is probably the most common type of database that we can use. And you'll see that once you introduce relationships, then you have to think about how to organize the data. So that's very much what the discussion is going to be about in this lecture. So we need databases for any number of reasons. We want to be able to pull in data from multiple sources. In most of what we're doing in the classes, we're talking about data that are provided by different administrative agencies. We might be talking about wage record data that come from businesses. It might be individual level data that come from a survey. It might be case level data that come from the human services agencies. It might be education level data that comes from an educational institution. So there are many different sources, and they'll come with different levels of granularity. They might be individual, they might be family, they might be coming at a different time period, different temporal granularity, and different levels of spatial granularity. There could be some at a zip code or at a county or at a state level and so on. And that, of course, creates a challenge when we want to link the data, when we want to combine data from different sources. We want to think about a database structure when we want to store data efficiently. It's a lot cheaper nowadays to store data than it was before, but there's still a cost associated with storing it. We want to pull it in so we can analyze it as quickly as possible, so we're not trying to waste time. And then also we want to provide the data to other people to work with in the analysis. So those are the kinds of reasons why we need to have a database system. So the old way in which this was done, and I'm going to call out my colleague Ophir Frieda and his book on this, who got a really good description of database applications, as does our textbook. But originally it was just based on file systems. And so you will recognize something like this where every file system had its own structure. So sometimes these are called native systems. So you've got a payroll system where you need to administer payroll. And so you're going to just send out that data, structure it to do payroll. You've got an inventory system. And what you want to do is you just want to take inventory of what you've got in the organization. You've got a marketing system. Now, and everything had its own logic. It had its own native way of doing things. So that's all well and good, except the problem that you run into is it's really a mess when you try and combine information. You'll have the same data put in different places. You'll have the same data that have different values depending on when it was put in place. It's very difficult to update. When you're trying to access it, you've got to remember or figure out how to pull the data in. And you also don't have a way of ensuring that the data that you pull in from one system is the same as data that's put into another system. So anyone who's worked with data, and usually when I do this lecture, people are nodding their heads, know that when you're dealing with legacy systems, it can be very, very confusing, very difficult to keep updated and so on. So that is why database models became so important. And really, Ian Foster, when he first wrote this particular chapter in the textbook, he said, this is probably the most important chapter in the textbook. Because if you are going to be working with data, the very first thing that you want to do is to make sure that the databases make sense. So if you go back and look at the work that people have done historically, there were different types of systems that were built for different types of use cases. Another colleague, Parko Nathan, has a very good book on database management that talks about the information management system that IBM instituted. What's really happened over the past, I'd say, 20 years is that relational databases have become the workhorse of the way in which we do business, certainly in social science. There was a craze for a while there for object-oriented programming. We're not going to talk about that in a great deal of detail, but just wanted to let you know that people have thought about this a great deal. And we're, as is usual in these videos, just going to pick out one particular thing and drill down because we think that's most useful for you to look at. So what is a database management system? Essentially, you've got data, and what you want to do is you want to organize it, store it, manage it, and interact with things. And so it's essentially a way to store data, to query it, and really importantly, if there are any transactions that are being made, you could think of administering a welfare program or administrating an unemployment insurance program, you've got to provide support for that. And if or when a crash occurs, you can recover that. And as I said, we're going to focus in on relational databases here. Millions of different examples. You've all interacted in some way with a healthcare institution. You've got patient data, financial institutions. Obviously, in our classes, we talk a lot about educational institutions, and you can think there are data on students, there are data on courses, there are data on registration, data on grades, and so on. So each one of these has a database management system that is providing a way for those different levels of transactions to talk together and be usable. So one way of thinking about this, looking back to the previous example, when we had payroll, inventory, and marketing, you build a database system on top of those separate entities so that you've got a more organized way of thinking about the way in which data are handled. Your book has a very nice example. Now, lots of times you don't have to have a database system for every single time you interact with data. Lots of people go a very long way with spreadsheets and text files. Now, the challenge with anyone who's worked with Excel spreadsheets, for example, it's very quick to use, very handy, very intuitive, but it's very hard to replicate the analyses. And you'll do a spreadsheet and everything is one-offs, so you don't expect to repeat it over time. Once you start getting into more work that's going to be replicable, you need to think about how you're going to handle it. So there are a bunch of statistical packages. Obviously, we have R, we have Python, we have in Stata, a decreasing number of people use SAS and SPSS. And those are fine. They're not database management systems per se, because essentially they start with assuming that you have a data set. They're not really set up to manage and manipulate and think through how the data should be stored. We're going to spend most of our time today, or all of the rest of this video, in talking about relational databases. And you've got structured data, you want to have some kind of version control, provenance control, because things are going to change, and you're going to want to be able to share it. The book talks a little bit about NoSQL databases. I'm not going to talk about that so much in this video. So what's a relational database? You can obviously see that they store data records in tables. So one of your fundamental construct is that you have a table that you're working in. You've got records in rows in that table, and then the relationship across the tables are defined in a schema. You learned in your online training about SQL, and the relational databases use that structured query language in order to go in and interact with the data. So that's essentially what a relational database looks like. It's called a relation because that's the way in which the table is structured. The rows are tuples, the columns are attributes. And, you know, kind of the defining characteristic when you're dealing with the relational database, you have to write down what a schema looks like. We're going to talk about that next. So, you know, if you think about a way of structuring a model, you might want to think about a network type of approach. And you think about people going to a university or an individual named Oliver, and goes to a university and graduates and then goes off and works at different companies. And so the network shows the interrelationship between all of those. That looks a little bit like a spaghetti diagram. So it's not particularly helpful for the type of structures that we're interested in. A hierarchical model, you've got Oliver at the center, and then you've got information about where Oliver graduated and where he worked, and then the places within where he worked and where he graduated. Now, relational model talks about keys. So you've got an individual called Oliver, you've got a list of places where Oliver graduated and a list of places where he worked, and the key between those two things is the person. So the basic idea here is you want to develop a set of keys which links these two tables in a relational manner. Again, from the book and from a class that we ran earlier in, in 2019, we had quite a complicated set of activities where we were interested in looking at individuals who earned doctorates. So the core of this was an individual. We were interested in the survey of earned doctorates. And what we were interested in understanding is what research had they done. So we linked the data on each individual to the research grants that they were on and the payroll activity that they had had. Grant activity, what research grants they were funded on. So you had information on the grant award. So here, the grant key, which was the information about how they were paid, was pulled out. You wanted to have some information about the university at which they worked. So you had a key that was associated with the university that structured information about the patents at that university, the aggregate amount of research that was done at the university, and so on. So you can have quite complex schemas when you're pulling data together from multiple places. There's lots of pros and cons for a database system. It's really good for handling tabular data. The relations provide you with a way of normalizing the entities over time and enable you to create those links. It's very logical. It makes a lot of sense. And almost all packages use it. SQL is a very, very common approach to loading the data. The challenge is it's a lot of work to think about how you're going to design the schema. It's when data are unstructured, it can be really difficult. And when you have huge amounts of data, it can be really difficult to scale up. So that's kind of the summary of what's going on here. I've got some questions that I'd like you to answer. You know, what do you use in your work? if you go and take a look at the textbook and think through about what the advantages are of a relational database model, what would be the main advantages? Are you using one now? What are the disadvantages? So I look forward to hearing your thoughts on that. Thank you.